right, good morning, everyone.
You got the clicker.
I got the clicker.
Good.
Thank you. Thank you for coming for day 2. Particularly, thank you for coming to this talk, and so early, so appreciate that. The talk is around big, dark data, right? So we had a couple of interesting premises that we wanted to discuss in this one today, but they were much more oriented towards the technical side of things, so hopefully this will be interesting. I don't know if we're doing a panel at the end, so just in case if there's questions you want to do, at the final slide, once we do the questions, just shoot them there. But again, there might be a panel later, still to be confirmed. My name is Federico Charosky. I'm the managing director of Quorum Cyber, and also Big Red Button, which is part of our services. I've been doing cybersecurity since or what we used to call it, information security, to be honest. So the premise for today's talk really was around one particular question, which is, as we adopt big data in cybersecurity, as we start collecting the data and analyzing it, and we have machine learning to go through it, what if the insights that we get from them are wrong? What happens if we can't trust the output? And how do we go about ruling whether it is right or wrong, the insight that it's providing us? So in order to do that, I wanted to guide you through an actual example. And this example is a live example. This is something that actually happened in our SOC. So in Quorum Cyber, we run a cybersecurity operations center, but we're a little bit different in that we run on Microsoft technology. So we are the first SOC to have built a full stack SOC offering just using Microsoft stuff. So we don't do any of the traditional SIEM vendors that you would normally consider. The reason we did that is because it was cloud native, and they were doing some really cool advanced technology stuff, but also because you could leverage all the investment that Microsoft is doing in machine learning. So instead of putting it as a feature of a product that I bought that you might not know whether it actually has it, Microsoft has invested billions of pounds into actually doing some really cool stuff around big data management and machine learning and AI, and I use that word very carefully, but I mean, if I'm going to trust anybody, it's going to be Google, it's going to be Amazon, or it's going to be Microsoft to actually give me something of real interesting value. So we use Log Analytics and Security Center and Security Sentinel and Windows Defender ATP and Azure ATP and MCAS. All these things are the stack that we use to run a SOC practice. And all that it does is it provides all that data to us analysts and to the engineers so we can build the MITRE use cases and the attack taxonomy and all that stuff. But it also enables you to drink from that Microsoft threat intelligence and Microsoft machine learning. And that comes in as another stream of insights into the SOC. This particular day began, like most days begin for us, with an alert. And this alert was not an alert from a use case that we created. This was an alert that came through a machine learning use case created by Microsoft. And that alert looked pretty much like that. I'm not sure if I have a pointer in this. I do have a pointer. Cool. So, as you will see, it said there was suspicious DNS resolution. The particularly scary stuff in this one was, it was a DNS tunneling, potentially. But as you can see, you don't get a lot more data out of it. So this is our kick. This is our trigger, right? And this is what the analysts start working on the back of. You have the affected host, and pretty much that's it. So when you receive an alert, you kick your playbooks, you get your team in gear. The first thing you need to do is enrich that data a little bit to understand what you're looking at, and then decide whether it's an actual thing or not to begin with. Then you decide how critical it is, and then you decide what you're going to do. In this case, what we know is that a P2 alert, and the reason we raised it as a P2 priority 2 alert is because we could actually see that the affected asset was a domain controller. So now we know we have a potential DNS tunneling in a domain controller. That's not a good start. That's actually a day you need to really earn your bucks. And just as a matter of curiosity, how many people here know what DNS tunneling is? Okay, so a low percentage. So a DNS tunnel attack is a technique, really, that an actor can use for a number of different things. But usually it's either signaling, that means they're trying to reach call home to get commands or to alert that they compromise something or to exfiltrate some form of data or to actually do a proper massive data exfiltration exercise. So they're using the DNS protocol, which is a protocol you don't sometimes scan so much. You usually tend to forget about it to actually exfiltrate a whole bunch of data, which is not particularly a good thing. So it's a bad thing. So, but when you're suffering from DNS tunneling in your domain controller, this means that there's been a whole bunch of stuff that happened before that. So an actor would have had to get access to the environment, usually using non-privileged credentials. Then they would have had to troll inside the network a bit to find privilege escalation, then find the domain controller, then do stuff on the domain controller to then use DNS tunneling as a technique to exfiltrate data or signal out or whatever. So we were only getting that alert at the end of the kill chain, if you want to use a marketing term, but we missed everything before. So the team started to panic a bit. And the problem was the alert that we had didn't give us any other information other than, hey, there's a problem. By the way, that asset might be a domain controller. Good luck. Not a really good bunch of data for analysts to do stuff with. So roll up our sleeves, we need to go into investigation. This is what the first level analysts will do, right? They will grab the little data they know and they will go and conduct investigations to see what else they can find. The first thing that we find is, okay, so what are those DNS requests? We're seeing, it said, if you look at it, this slide, it said kind of hunt, if I point there, yeah, so thousands of domains being visited by 2 IP address, one of the domain controller. So we go look at the DNS logs and we go look at the DNS requests. The DNS requests look funkily weird. This is what the DNS protocol is sending, which starts scaring the incident responder. What you will not notice here is that although that string is constant, these strings over here are almost sequential. They have a predictable gap number of a couple of bytes. So that was awful, because that is usually indicative of somebody trying to call a designated list of hosts that are created by an algorithm. One of these could be live, and that's what that host then replies with a payload or the next stage or something. It's kind of weird and freaky. In a moment of true inspiration and creativity, one of the incident responders actually pings that weird string, going, I wonder what that happens. And one of the playbooks that we have, that said, actually just ping it, see what you can learn of that. And the thing actually replies with an IP address, which is mind-boggling if you think about it, because that's a really weird string. So we then go investigate that IP address. That IP address turns out to be quite weird stuff at first. So it's related to a host called Bearfruit.co.uk. That's not really what you would like your domain controller to be talking to in a sequentially generated number of strings through DNS protocol, and your machine learning algorithm by Microsoft telling you that that's a tunnel. So this is starting to get more data, right? So we then go run an analysis on Bearfruit and that IP address in particular. Threat intelligence start telling us that's a known evil site. We then see there's a whole bunch of other sites hosted out of that IP address. Things like gamingnuts.net, not really good things for your domain controller to be talking to. And then in another thread feed of like a forum with conversations about these IP addresses, they're saying that they're doing some phishing attacks from that thing and that there's an HMRC impersonating site. So this is definitely not a good day. And that's definitely not a good site. So on the same track, one of our network investigators is doing some contextual traffic analysis of that domain controller. So they're pulling all the NetFlow of that box. And this is a really cool, fancy thing that you can do with the Microsoft stack. So the Microsoft monitoring agent that you have in your boxes, whether Windows, Linux, whatever, it actually captures NetFlow of all that host, and it indexes that data into log analytics. So you don't need to go buy a massive packet analyzer or anything like that. You have all NetFlow data for all your hosts that have that. So we go pull the NetFlow. So what else is that box doing in that network? And we see that there's a particularly offending IP address that is, it's orders of magnitude sending more traffic than all the other boxes. And we don't know what that box is. So now we know that we have a box in an internal IP range that is sending massive amounts of traffic in terms of data compared to others. We then use Windows Defender ATP, which is like a sysmon evolution of it. We can pull the processes and the connections, and we see that actually those connections are established by the process in that box, which is LSAS. That's a really bad day. I mean, that's an authentication level type service and a privilege account. This is not good. So at that point, we triage the thing again. We now know a lot more through that enrichment process, through that playbook. We know it's in a domain controller. We know there's 6,000 plus requests to a risky site. We have that site called Bearfruit.co.uk, which is not a nice thing. We have a critical process in our domain controller connecting to a box we don't know inside our network, sending massive spikes of data. At that point, we decide to triage it as a P1, which then means, again, it's escalated in the team. There's another team that gets involved, and that's when all hands kind of go on deck at that time, right? And everything gets unfurled. So the first thing we do is we go back to that DNS pinging that we did, but actually this time we don't focus on the IP address, we focus on the string. So that string is weird. You shouldn't be able to ping that, right? Because that is not a domain. That's not a .com thing. Unless you're using some weird encoding that DNS can still resolve, that thing should not be pingable. That's not a host. So we start spending some time looking at what's going on. And what's going on, turns out that the investigator that did that is actually doing that from home. And they're using a major ISP. Might rhyme with Surgeon Media. And she's just postulating it. And what that major UK ISP does when you ping something that doesn't exist, it does DNS hijacking of you, and it redirects you to a site that is trying to sell you ads, which is the bearfruit.co.uk. So if you ever try to ping or reach something that doesn't actually exist as a thing, like a random string, the major ISP will say, well, but you can buy this ad here in this webpage. It's wonderful. So they're actively intercepting all your DNS traffic to sell you ads. Just saying. So that's one whole side of the investigation gone. So we now don't have an evil side trying to talk to our domain controller. That's a side of relief. But now you start thinking, so what do we know that is true? Well, let's go back to that internal IP address that wasn't in the connection. Well, actually, it turned out that the customer had not updated the asset register. We did know about it in a previous incident the day before. That was a new host that was connected in a different region that wasn't under the purview of the SOC. But we had learned about it in an incident the day before. They never updated, so we had missed that. Interesting. That internal IP address turns out to be good. So what do we know at this stage? We don't know anything other than that original alert. So we go look at the DNS traffic in a lot more detail. But in particular, now, instead of just looking at what is it that it's trying to ping, I try to pay attention to the query type. And the query type leads you to a protocol called TSIG and TKey. TSIG and TKey. How many of you know what TSIG and TKey knows? One person. You're the only one that knows. It's awesome. So this is an encryption protocol between DNS servers. So basically, it's a handshake that domain controllers and DNS services can do to exchange secure DNS information. Microsoft, in all their kindness, implemented their own version of TSIG called GSS TSIG, which, if you go and troll through really weird Microsoft documents that have protocol examples, shows you what it looks like. In particular, that's an example resource name. And if you look at it, it looks mysteriously similar to the string that we were doing. That's an RFC-compliant Microsoft TSIG handshake documentation. So that traffic that we were looking at is now encrypted traffic between two internal hosts that actually both domain controllers, so they're just doing their job. So the premise in the original question that I asked, what happens if everything that big data told you was wrong, becomes real because what happened there after investigation was Microsoft's machine learning misfired. We investigated the hell out of that traffic. We looked at it in depth, and we couldn't find anything in it that wasn't just normal DNS traffic that is encrypted at TSIG globally between domain controllers. We raised this to Microsoft, and 3 weeks later, they confirmed, oh yeah, it's a known bug. I'm going, wait, what? We have 20-something customers on this. They all have domain controllers. They all use DNS. How is it firing for one, but not all the other customers? No, we're tracking about it. Sorry about that. And the problem is, it didn't give me any clue as to why it had reached that conclusion, right? So as an investigators, we had to invest a heck of a lot of time to find something that Microsoft had determined to be an oops moment. So to wrap this one up quickly, there's 3 conclusions for me and the day. The first one is, big dark data analytics is dangerous. We cannot rely on a black box telling us there's something going on there. We need to demand transparency of how they reached the conclusions that they have reached so we can validate it, so we can understand it, so we can improve it, so we can learn it. And the problem is, more and more the vendors that are trying to really do this, so not the ones that are using it for marketing perspective, I just want to tell you we have machine learning. The ones that are actually processing petabytes a second of data, they have the algorithms, they have the technologies, and they're pushing their R&D boundaries in this. They're not giving us that data. So when you work with AWS, when you work with Google's backstory, when you work with this, you don't get any of the transparency, you just get the output. And you kind of need to take it at face value. If you don't have all those other signals and the skills and the teams to go do that, and something just tells you, by the way, you've been hacked and you're leaking terabytes of data, how do you know? How do you know what to do? How do you, to talk about GDPR implications, how do you know whether you should be alerting all your customers that you've just lost the entire customer database? and this thing told you it did, and it's Microsoft, so you take it with face value. So my point here is we need to demand transparency of how they reach those conclusions. The point number 2 is we seem to be forgetting that big data in itself is it's a means to an end. Big data is not a thing that we want to achieve. Big data is something we want to use to get information out of it. And more importantly, you want to use it to actually distill from that information knowledge. And we're at a stage, we're still at a stage, and I think we're always going to be at a stage where you cannot delegate that to a machine learning algorithm. That process requires still today human interaction. You need specialist inside investigation knowledge, creativity, correlation, that at the moment, given how effective that machine learning algorithm was, still relies on human knowledge and experience and insight. And we cannot just give it up. And the third and last one is, you should probably choose your ISPs carefully. Thank you very much. Any questions for now, or do we want to do it in the panel later? I'll count to 5. 1. Yep, sure. Hold on. Apparently, I have to throw this at you. It's a microphone, they say. Whoops. Do cyber. I don't do.
Thank you for not throwing that at me. So for your example, what would transparency look like? So what would you expect Microsoft to be able to say about the initial alert?
Well, I would have liked to see those 5,000 logs and queries that they said were strange, for example. They should have given me access to the base data that enabled them to infer that something was up, right? So DNS traffic is something that happens in troves of volume, right? You get thousands and hundreds of thousands of that out of any organization. Why those 5,000? Give me something. Was it a weird destination? Did the destination match a known bad actor, like through threat intelligence? Did you have a spike in that box that you didn't used to? Something changed or something became anomalous in that particular traffic that it hinted the algorithm to say something's up here and you need to go say it. And when you say particularly, and I guess this could be a taxonomy or a language question as well, they could have said something weird is going on in your DNS, go look at that, but they specifically said this is DNS tunneling. That's a very precise diagnostic that they've applied there. And if they're just throwing these terms loose and irresponsibly, is going to lead all incident responders to apply a series of playbooks and thinking and context that has nothing to do with the actual breach, or could have nothing to do with the actual breach. So again, if what we're trying to do here, which is the ultimate game, is stop bad guys, I need that data to be either trusted, or if you don't trust it, at least explicit, so that I can go then make my own assessment of it and use that sensor as an input as opposed to the sole determinator of evil. Hopefully it helps. Any other questions? One more here. Yeah. Food fight. I'm sure we're insured for that.
Hi, Federico.
Hey.
Okay, so one of the questions I have here, when you said that we have to demand transparency, I don't know, we are in the cyber stream rather than GDPR stream, but you know the concept in GDPR of transparency. So with all AI, I know that many of the CMs, all these engines, they drag a lot of data. So can we use the regulation to somehow ask the third party, your vendor, to be transparent and show you what they have in logs? Because I assume there you have IP addresses, DNS, but also you can have AD accounts.
Absolutely, yeah, the logs will pull troves of data.
And what you,
So it's an interesting question. I'm not sure I can answer it with any form of authority. So I'll give you a creative answer and take it with that. We can take it for discussion. There's two elements. I think, first of all, Microsoft, when they built this, they built it for an organization to consume for themselves. This wasn't originally built for a security service provider like us. We had to hack a whole bunch of stuff to get this to work that way. And they're leaning on that direction. But so in that leaning towards that direction, you will have to take a lot more of this into account, right? Because you're handling other people's personal data, other organizations that hire you as a, not as a controller, but as a processor. So we have a shared responsibility on how I process it, so on and so forth, right? So we can ask Laura next door about the implications of that. So I think there's a certain caveat there in that Microsoft built it for you as an organization. That data is already yours as a controller. The only thing you're doing is using another tool for processing it. And in the contract that you do with Microsoft, there's legal coverage for pretty much everything.
Yeah, but it's a lot to do with the raw data, because the ICO right now is very concerned about data ethics.
Yeah. So there's, and going into that, right, so what's the transparency with logs? There was a ruling this week, for example, which was milestone ruling, in that said that it was something around a company scanning emails and a former employee taking the company to court because they consider that a breach of their privacy. And the court actually said, no, actually the company has the right to scan emails because they're doing a fair and a normal amount of scanning in order to protect the company and its customers. So they were okay to do that. So that to a certain degree validates the legal ability that as a security provider we have to actually collect that data and scan it and analyze it and mine it for security insights. If I was giving that same log to my marketing team to say, hey, Mark is visiting that site 300 times a day, go sell him something, totally different conversation. But if my objective is to keep the company safe and I need those logs because that DNS log can say that your computer without your knowledge is talking to an evil host sending data, that's a fair and fair consumption of that data to get that insight to then respond. So I'm not saying that this is a settled conversation at all. I think we're going to see super interesting conversations moving forward. Yeah. Like, for example, if a former employee of a customer of mine wants his AD logs deleted from my tenancy, like how does that chain of events transpire? And I should probably have a legal answer to this. I'm going to say refer to my lawyer, but I don't know what that answer would be personally. Yeah. I'm sure my lawyers do. But yeah, it's a complicated conversation. Unfortunately, we can't use that for transparency of their decision making. So I think to a certain degree, because they use metadata, right? So when Microsoft does all this analysis, they use a ton of metadata of that data. And whether we can use the GDPR stick to demand access to how they reach that conclusion, pass, no clue. It'd be interesting. And I don't think they're not giving you that transparency because of private IP or they don't want to share it. I think that this is the first attempts at trying to embed machine learning as a signal into a decision-making process, right? And it's effective. Like 90% of the times it doesn't misfire. The problem is you never know whether this is one of those 10. And the less you can trust that signal, the less it's going to be relevant to security posture. So it's a tricky one. Did I not answer? I did.
Yes.
Yeah, all right. One more? No? Okay, thank you very much, and see you in the next track. Do we go straight to you? Yeah, let's go straight.